What's up, man? You want to give this a shot?
Oh, yeah, sure.
Yeah. So, first question, obviously, are you smarter than a fifth grader?
Probably not.
Nah, I'm pretty sure you are, man. Trust me, I think you are. So, I have 3 very easy questions and see if you could get at least 2 of the 3.
All right.
Very easy. So, and they all have to do with water.
Okay.
So, elementary physics, very easy. So, here I have 3 water bottles. And I painted the water blue with food coloring just to make it easier to see the water. But how I'm showing them to you, these 3 water bottles. By the way, another thing to take note is that all of these bottles are at rest, right?
Yes.
So what's the difference, how I'm showing them to you, between these 3 water bottles?
The orientation of the bottle.
Oh, you got it.
Yeah.
Can you put them in the correct orientation? Or I guess what will be right side up?
Right side up. Assuming that the foam is the bottom.
What would you assume that the foam is the bottom, if I may ask?
No reason, honestly. It's just, I guess.
Okay, okay. But you got it right. It is the orientation of the bottle. That's the difference. But can you tell? Can you put them in the same orientation? I guess all of them in the orientation they should be.
Yeah.
I guess that's what it comes down to.
Yeah, no. I'll just assume that this is the one that is. Oh, this is obviously on its side. What side? I don't know. From the orientation of the bottle, hard to tell.
I'll give you a hint. When you have air and water in a bottle, what direction does the water go always?
It goes down.
Okay.
Yes.
So based on that fact,
This is like this.
okay.
This could be, if the foam is the top, it would be like, if the bottom's this way, so it'd be like this, and then this would be like this.
Right. You got it. Yeah, you
If the
got
foam's
it.
the top. Yeah.
But here's the thing, though. No, but the foam's the thing is that
Oh,
the
it's the foam
foam
the bottom.
Yeah. Well, the foam's not going to tell you anything about the orientation. What's going to show you is the water.
Yes.
Because obviously, if you're looking at a water bottle like this, water doesn't behave like this. Water doesn't fill the bottle from left to right.
Yes.
And it doesn't maintain that. And obviously this one also, water doesn't stick to the top and the air rests on the bottom. That's impossible. That defies physics.
Yes.
So obviously the water is what shows us the correct orientation, air and
Yes.
water. Water's always on the top and air is always in the bottom. Water's always in the bottom and air is always on the top. Yeah. Would you agree? Yeah.
Yes.
Pretty simple, right? Okay. You got that one. So this next one is similar. I'm going to tell you the difference between these 3, but I just want to see if you could tell me which one's which. So in this one, I have a truck and it's halfway filled with water. And the differences in these is that one of them is at rest, one of them is accelerating forward, and one of them is accelerating in reverse. So if I was to ask you which one is at rest?
At rest, accelerating forward, accelerating backwards.
You got it. How did you know that, if I may ask?
At rest, it will be level. Accelerating forward, the water's going to push back. That's why in water trucks there are gates.
Yeah.
Same reason why it's moving forward.
You got it, man. You're pretty smart. That's pretty good. Yeah, so obviously what would be your definition of when water's level and contained? How would you describe the water? You said it right now, level.
Yeah, level.
What could be your definition of level, I guess, if I may ask, when water's contained and at rest?
Level, just flat, I guess. Yeah.
The correct definition, one-word definition, will be horizontal.
Yes.
Because level, again, has no deviation in elevation from any given point. Again, a horizontal surface, which is perpendicular to the vertical. Another definition for level, perpendicular to the vertical, right? So, yeah, you got the second one pretty easy. So the last one is actually even easier. Because we understand how water behaves when it's contained and at rest. Which one of these 2 represents level as we know it when it comes to the water? A or B, once it's contained and at rest.
When it's contained in
at rest.
And a container.
In a container, exactly.
Not exactly. Because when the water's in a container, it kind of bubbles up slightly. As you can see, that here it is kind of beveling on the side.
Okay. You're talking about like when you fill up a bottle all the way to the rim and it kind of
even here. So you can see there's a little edge right here.
Okay.
And it goes down, and this is actually where the water level is. This is just where the water is kind of reaching up.
Okay. Let's say we had a pool that was a mile long, for example. Pool, and the water's in there contained and at rest. Which one of these 2 will represent the pool, in your opinion?
This would be closer to the pool.
Closer to the pool?
Yes.
Do you agree? Yeah, obviously. Because again, water doesn't have a form.
Yes.
It always collapses and forms an equal surface, which is level, which is horizontal. So yeah, this is obviously the answer, how water behaves. And the water shows us that. So the real reason I'm doing this is because over 95% of the population, including myself and maybe you, have been tricked to believing this is what level means, even though we know it's this and water shows us that. You want to know how we were tricked? do you believe the Earth is a ball like this, for example,
Yes.
in outer space? Yeah, so these are official NASA images, and they're 10 years apart. This one's from 2002, and this one's from 2012. And they admit that they don't have a genuine photograph of the Earth as a ball. So they admit that all of these images they show us are all CGI.
I know. These are edited.
Yeah, these are
The Earth isn't a perfect sphere.
exactly. So these
Yes.
are what NASA shows us, though. This is what they depict the Earth is, and they actually admit they don't have a genuine photograph of the Earth from space. So if I was to ask you, why do you think that is?
The reason is because these just look prettier.
So why can't they take a full photograph of the Earth from space? In that question.
Well, they have some. It's just that they edit them because these look prettier. Most people don't want to see the world as a oblong shape because the world is kind of. I think if I remember correctly, it kind of bows out towards the top of.
Well, to the side in the equator, they say the equator bulges out.
Yeah, and then it's kind of because of impacts that the world has, kind of dented in a little bit as well.
Okay, sure.
some
So
locations.
again, NASA claims to have satellites orbiting the Earth, so they need to know the radius of Earth, the radius of orbit, if they're supposedly claiming the radius of Earth.
Yes.
So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile it has to increase. So again, if we went out to a giant body of water to physically measure for this curvature, they're trying to tell us, like a lake, for example, they're trying to tell us that the surface of that lake is bending 6 feet in 3 miles, for example, and 66 feet in 10 miles. So that's like a 6-story building over a 10-mile, across. So again, physics is going to show us that that's impossible because water doesn't have a form. It cannot maintain a shape on the surface. It always collapses and forms again a horizontal surface. But they're trying to tell us that to deny our experience and deny our common sense and believe that water has the ability to maintain a curve when it's contained at rest. But that defies physics. That's like claiming you can walk on water, but that defies physics, obviously. So this will be the #1 experiment to debunk the ball Earth claim, a physical measurement of the Earth, water in specific, because they're trying to tell us that the oceans are bending around a ball. But I don't know if you heard of the term sea level.
Yes.
So again, sea level meaning horizontal, meaning the oceans are are basically continents are just across the way. They're not bending and going under a ball. So if I was to ask you respectfully, what's the #1 proof that makes you believe that the Earth is a ball?
Just general physics.
Can I ask in specific what physics?
The laws of centrifugal motion. We can kind of write out in mathematical terms how the water is sticking to Earth.
Okay, so you're talking about like the redefining of level, because you know that they redefine level on paper to explain away how level works on a globe, and the definition is equal distance from the center to the outer circumference of a sphere. So that's how they refine level on a globe. So it's equal distance from the center to the outer circumference. Does that make sense?
Mm-hmm.
So that would make a perfect sphere, equal distance, but that contradicts their oblate spheroid claim, if that's what they're redefining as level. So that's a contradiction right there. But again, if we go to physics and just go with what we know, again, water can bend. That's an impossibility. It doesn't matter how large you make the container, the surface will never bend. You can make it 10 miles long, make it 20 miles. So every dam, lake, anything that has a body of water that's contained, the surface is always going to be.
Water can bend.
I mean, when it's being poured
It's
out.
bending right
Oh yeah,
now.
it has to be contained though. Oh, you're talking about
Yeah, it's bending right now.
But it has to bend at this rate over the distance of
I
time.
mean, there's a lot more water, but even on a small scale, you can tell that the water's
Even
bending.
even if I gave you that it's millimeter, because I see it perfectly level, but you want to say it's bending slightly up on the sides all
I
the
forgot
way
what the
around.
exact term is because I learned it in the exact term in high school.
So you're saying because it is a slight bend here that proves to you that the Earth is a ball?
Yeah, well, it shows that water can bend. So
Okay.
that refutes your claim that water can't bend immediately because the water is bending here.
Well, the claim again, it's the radius that they're giving us. There has to be 6 feet of curvature in 3 miles. There's no going around. This is geometry,
Yes.
based on the radius and the dimensions of the Earth that we're being told. There has to be a 6-foot gap between a level structure and the surface of the water in 3 miles. But if we actually build the level structure over a body of water, the distance is going to be equal all the way through, because again, water will not bend down and stick to a ball. That defies physics, as we know.
Well, no.
So-
Because even if you wet a ball, right?
Yeah,
So what we can do to test this is wet a ball.
sure.
Then attach that ball to a string. Once that ball is wet, spin the ball. Just go as hard as you can.
Right.
Stop. And then hold the ball, touch the ball. If it's still damp, that shows the water can stick.
Oh yeah, I agree. Very small amounts of water does. Even when I take a shower, water sticks to me. Yeah,
Exactly.
yeah. But a large body of water. We're talking, thousands and thousands of gallons. A large body of water
way
contained.
larger. There's a abundance of water.
So let me ask you this then. So you're justifying this curvature rate just because might be millimeters of.
Well, this is taking into account that we're moving really fast, and Earth is massive compared to you and I.
You talking about the radius? Or?
Oh no, the water sticks to Earth because it's so massive, and because it's so massive and moving so fast through our galaxy, the water is sticking on through centrifugal motion.
Okay.
The same reason why a water will stick to a ball, and the same reason why water is sticking kind of up on the bottom.
Okay.
Why it's reaching up.
You're saying that you're comparing the ball like the water sticking to the ball, the Earth, I guess.
Yes.
Using due to centrifugal force, like when you spin water in a bucket.
Mm-hmm.
So the Earth is not like a bucket. The Earth is not a ball. Is not a container.
Well,
so
not like water in a bucket. Water on a ball.
If you spin water on a ball, does the water stick to it or does it go in every direction? Let me show you a quick.
Because you have to add the water in scale.
Yeah.
If you add a drop of water, that won't stick because it is way larger than what you would see on Earth. You'll never see something like a drop on here because a drop on here would be something like the size of the United States.
Okay. Well, this is what happens when you spin a ball with water.
The
water flies out in every direction.
That is a lot of water. That is way more water than is on Earth by scale.
By scale. Okay, even if it was. So you're saying that. So
that'd be another Earth-sized amount of water, which is not possible on Earth. It'd be like if water reached out past the United States.
Right.
Or if.
So you know the depth of the ocean is what you're saying then?
Well, I forgot the exact number, but
you know the deepest humans have ever gone in the oceans, allegedly?
Mm-hmm.
It's only 8 miles, which is not even scratching the surface.
I don't believe that is true, actually, because the Mariana Trench is deeper than that, and we've gotten about halfway through.
Well, it's probably less than that, because again, you could look this up, but again, and same thing on Earth.
Yeah.
The deepest we've ever drilled is 8 miles as well.
That is true for 8 miles because it gets too hot.
Yeah, exactly. So the ocean is actually the pressure increases too high that obviously you can't.
Oh no, but we've gone way farther than 8 miles.
All right. Well, again, physics. Again, if we went to any giant body of water, again, the surface will never bend. The horizon. Another thing about how would you describe the horizon? This is 20 miles in the sky. How would you describe the horizon geometrically?
That horizon is flat.
Exactly. I would say the word horizon comes from the word horizontal.
Yes.
So it will be impossible for the horizon to be horizontal and rise to eye level if we were on a ball and we elevate up. So the horizon, again, it should never rise in front of you, and that's what geometrically happens, which would be impossible on a globe as well. All right. And then the number one proof, believe it or not, I know water is one of the top proofs, but believe it or not, a lot of people think gravity proves the globe. Mm-hmm. The irony is gravity actually debunks the globe.
How so?
Okay, so gravity, and you know that when you accelerate a bottle with water, the water goes towards the back and pushes towards the front, right?
Yes.
Exactly. That happens every time you accelerate or apply a force. So I don't know if you knew, when you release an object into free fall, there's actually no force acting on it. Are you familiar with Einstein's theory of relativity?
Yes.
Yeah. So he acknowledges that there's no force acting on a free body, on a free falling object.
Yes,
so he came up with the bending and warping of space, and the reason why is because when we accelerate, when you release an object into free fall, the fact is the Earth is not pulling it towards the ground. Yes. What's happening is the Earth is actually pushing up. So you're not being pulled towards the Earth. The Earth is pushing up against you. So force only exists as a push.
Pull. There are multiple vectors of force, though. There is a force of gravity pushing down, and there's a force of the Earth pushing
But
up.
that contradicts the fact that there's no measurable force in free fall.
No, that doesn't. Because if you're in free fall, right, there is no acting force on you. You're in air. Sure. Other than gravity. In a perfect vacuum, there is no force acting on you. But we're not in a perfect vacuum. We're in, obviously, I can touch air around me.
Exactly,
I can feel
exactly.
it. So we're not in a perfect vacuum. On Earth, there is a natural force which is pushing up, and there is a force of gravity pushing down. There's the reason why we have the ability to jump, but we don't go through Earth, and we don't fly away.
Okay, so you're saying, so a pulling force is where you're saying gravity is, right? Where you would say?
Yes.
Okay. So this is why I say pull as a force doesn't exist, is only a description of direction. Push is the only force that exists. I'm going to explain to you why. So if you want to, inanimate matter cannot move on its own. Would you agree? It requires an external force to move matter. Matter cannot move on its own.
Yes,
right?
that's true.
Exactly.
It requires some sort of
Exactly. So if I wanted to move this phone, I have to push it in that direction. You know, if I want to move it this way, I have to push it in this direction. You know, in any direction, I have to apply pressure.
Yes.
So again, exactly. So if you're talking about pull, how can pull as a mechanism move an object without applying pressure, which is a push?
Well, you can't. You need some kind of pressure.
Exactly.
You have to exert more force than what is being applied to it.
So the pulling force of the Earth that we're taught in school, a pulling force, that this gravitational field doesn't exist. So the only force that exists is the Earth's motion pushing up against you.
Well, no, because even with that, right?
Yeah.
The reason why it is stationary right now, well, we can consider it stationary. Is because
relative to the Earth.
There is a force applying to it that's pulling it down.
No, it's the Earth pushing up against it. That's the reverse.
The reason why you have to push it is because you have to push harder than the force that's being currently exerted on it. You have to push past the friction that gravity is applying to it.
Yeah.
It's like, I forgot that formula, but it's something like sine, cosine, something with sine and cosine.
Right.
But this is a stationary object.
Yeah.
I'm applying more pressure than whatever the friction is.
Yeah, I agree.
And it's moving.
Exactly. Push, being a push.
Yes.
How can you pull this right now?
Oh, I can't pull it right now. Well, I can pull it right now because I can just do this.
But you applied pressure on it. That's push.
I'm applying pressure down.
Again,
but if I had a string attached to this, I can pull it this way.
But that string has to be applying pressure as well. You have to make like a little hole.
It is applying pressure.
That's my point. Pull, let's say you have a door handle. When you pull something, you're technically pushing it towards you, but we say pull. When something is pushed again towards you, towards the observer, it's called, we call it pull, but the mechanism is still pressure, it's still push.
Yeah.
So the only force that exists in nature is push. In order for something to move, something else has to move it. So again, this gravitational field that we're being told doesn't exist because when you release an object, it's not the object accelerating towards the ground. Again, it's the Earth coming up to meet it. So it's the Earth's motion that's pushing up. So another way we know that the force is up and not down is, an accelerometer? Have you ever heard of it? Yeah. So every cell phone, you could download the app, has an accelerometer. You could download an accelerometer app. And what that accelerometer app does, it detects acceleration. So if you're holding the phone this way, for example, and you accelerate in any axis, up, down, left, right, it's going to register that force, that acceleration. Guess what happens when you put it into free fall? It registers 0 acceleration, showing you that there is no force accelerating objects towards the ground. So again, gravity is not a pull of the center of the Earth. It's the Earth moving upwards, pushing up against you. So if we could prove that that's the case, and it's the Earth pushing up against us and not being pulled down, how would that work from a globe? If it's the Earth pushing up, meeting the objects, moving up, it wouldn't work from a globe. That would mean the Earth will have to either be expanding or it would just explode, basically. So again, this whole idea of gravity, that's why gravity as a pulling force is always going to be a theory. I don't know if you knew, gravity is a theory.
Well, yeah,
they haven't physically measured this gravitational force.
As any concept in science is a theory.
Well, not everything, because science is the method of proving things. It's measurable, testable, and repeatable. So I can test that steel is stronger than wood through the scientific method by putting it into practice. So we could prove that steel is stronger than wood. And I can prove that humans cannot breathe water, because humans would drown if they breathe water. So these are very basic fundamental facts about our reality. And force, again, how force works is pretty basic as well, being a push. So let me ask you this. Is there a possibility that we have been lied to about the nature of the Earth, or are you 100% convinced that it is a ball?
Oh, no, I'm 100% convinced.
And what convinces you that it is a ball?
From what I know of science and the other heavenly bodies that we have.
What do you know of science again? Because I kind of missed it, I guess. If you can
sorry. I'm a bioengineering student.
Okay, so what about science that physically shows you that it is a ball? Did you say centrifugal force?
Which doesn't. The law of orbits, Einstein's laws themselves.
So orbits require gravitational pull, right? Again, being a theory. And again, if it's the Earth pushing up against you, then how do you have orbits? You can't. Again, the whole idea of outer space is all fueled by this theory of gravity of being a pulling force. But the fact is, again, Earth is not pulling things down. It's just moving up. And again, when you release an object, let's say, hypothetically, nobody knows the speed of the Earth because nobody's been outside of it. Let's say the Earth was moving at 1,000 miles an hour right now, and I'm holding it right now. Everything's moving at that same speed. As soon as something's not connected to the Earth anymore, it starts to lose that speed. So that's why it only appears to go down, but it's us that's coming up to meet it. the ground and everything else that's attached. So it's, moving up to meet it. So that's why this never accelerated down. It's the Earth that came up to meet it. And that's what physics shows us.
So what you're saying is that we're constantly moving up.
Exactly. Yeah, the Earth is constantly moving up. Exactly. It's a constant speed too. It's not accelerating. Because that's what they try to misrepresent the motion of the Earth by claiming that it's accelerating. That would mean that our weight will have to be increasing as well, which is not. Our weight is constant, meaning that the Earth's motion is constant.
Well, if we were accelerating, our weight would have to be decreasing.
It will be increasing. Yeah, because when you apply more pressure to an object, that because of inertia, it's going to increase that resistance the more you push. Exactly. So our weight will be increasing because of inertia.
Oh yeah, I know.
Yeah. But again, another test that shows that it's the Earth pushing up is when you release a helium balloon, what direction does it go?
It goes up.
And why do you think that is?
Because helium is lighter than air.
Yeah, and what about the air being heavier that pushes the helium up?
Well, the nitrogen content.
What about the nitrogen content? What creates the motion, I guess?
As an element, nitrogen is just denser than air.
Okay.
And nitrogen is denser than helium.
But why doesn't it push it left, right, down? Why does it push it up? It is more dense,
because,
I agree.
Just like a ball, like the ball pictures that you had, like balls floating on water, it just goes the direction where it is least resistance, and up is the direction of least resistance.
Okay, so let me show you this real quick. Just real quick before you go. And
But also, balloons will go horizontally if there's wind applied because the horizontal pressure.
Would you agree because of buoyancy, right?
Yes,
buoyancy.
Yes.
Did you know that buoyancy is a force?
Yes, buoyancy.
Exactly.
Is a force, yes.
So I recreated buoyancy in a container, a cargo van, and again, the more dense material pushes on the less dense material only when the container's in motion. And here, let me show you. So here I have a helium balloon, it's pink, and then I have an apple, obviously it's red. But I accelerated the van in this direction, in this one. And obviously, we see the helium balloon being pushed in that same direction. Why? Because it's less dense in the air. Mm-hmm. So what happened was when I accelerated the van, the back of the van, the solid door, started pushing the air because, again, the air wants to remain where it's at. But what that did is created a pressure gradient in that direction of the force because I accelerated in that direction. So what happens is the air, because it's more dense than the helium, it also pushes the helium in that same direction. Because buoyancy, it's an effect of a force, or in other words, an effect of a contained system that's in motion. That's what buoyancy is.
Yes, but the air in this case is moving backwards.
Well, it appears to move backwards because the van is moving forward. The air wants to remain still.
It's not that it's appearing to move backwards. It is moving backwards.
So you think the apple's moving backwards too?
Yeah. If this is the way you're going, the apple would be moving this way.
Well, it's only apparent because the camera's also moving with the van. But if you're looking at it from the outside, the apple wants to remain in the same position in space. It's just the whole system moved forward, but the air's not dense enough to push the apple.
But just like the apple, the air is moving with the apple in the same direction. Helium is lighter, so it's moving when all this air pushes this way. The pressure of that air pushes the helium balloon this way.
And what's pushing the air? The van. The van.
Yeah.
The container that's in motion, exactly.
Yeah.
So when we let a helium balloon here on Earth, the air's pushing it in that direction. What's pushing the air?
The air is kind of just here.
So the air's not moving up to push the helium up?
Well, I guess air is constantly moving up, but it's just kind of dense.
So how can the air be moving?
Settling.
How can the air be moving up if gravity's pulling it down? Supposedly, that's where gravity is just a theory. The only force is up. And I can show it. And I've shown this with different states of matter. So air bubble and water. Again, I push it. The air is less dense than the water, the air bubble, and it gets pushed in that same direction. I accelerated the container. That's what buoyancy is. It's an effect of a contained system that's in motion. Because again, the air and water cannot push itself to be able to push something less dense. It's a chain reaction, and it all starts from the Earth's motion. So again, gravity, it's a push, not a pull. And again, it would debunk the globe entirely because you can't have a globe expanding in all directions. That's retarded. No offense, but again, the irony: a lot of people think gravity proves the globe. The fact is, gravity actually debunks the globe. And that's why it's the number one thing they teach us in school, and it's in every movie and every TV show. It's part of the indoctrination for everybody to accept that objects are accelerating down, and the fact is, it's the Earth moving up. And that's why flat Earth is one of the biggest psyops as well, because over 95% of flat Earthers and almost all content creators that do flat Earth content all claim the Earth is motionless. So now they're pleading for a magical force that can accelerate objects down and up at the same time, which defies physics. You can't have something moving in opposite directions at the same time. You know what I'm saying? How can an apple fall down and a helium balloon push up? That's two opposite forces in opposite directions. That's retarded. The fact is the Earth pushing up, and the air is not dense enough to push an apple up, so it only appears to go down. But the apple wants to just remain still. Again, matter just wants to remain motionless. That's part of inertia. and requires an external force to move it. So, you know, the force is the air, again, it being dense enough, it could push anything that's less dense, like helium, hot air, smoke, you know. But anything that's more dense, you know, goes down. But, I mean, before you go, do you have any questions for me? I know I kept you here for a bit, you know.
I know, we've been talking for like 20 minutes.
No, yeah. Trust me, I go to USC, you know, come here a lot.
Yeah.
I go to UC Irvine as well. Because, obviously, in my opinion, the education system is running away from this subject. They're not even touching it. So I'm having to come here and present basic facts, you know, basically to try and, you know, trying to have a conversation. Because they're running from the conversation, you know, professors, you know, and all that. So I mainly go to universities, again, just to challenge the current narrative. But yeah, I mean, here's my channel if you want to give it a look. I mean, if you don't have any questions, I guess you could take that with you. I have that thing.
Oh, okay.
Yeah. So, man, anything before you go? I mean,
No, that's it. I'll look at your channel.
yeah, appreciate it, man. Thanks for the chat. Really appreciate it.
No problem.
Yeah.
All right, I gotta get to class.
All right, man. Take care. Yeah, you too. You want to give this a shot? Yeah, so 3 very easy elementary level questions, and let's see if you can get at least 2 or 3. So the first one, I have 3 water bottles here, and they're all halfway filled with water, and I painted the water blue with food coloring just to make it easier to see. So all of these water bottles are at rest. So I want to see if you could tell me how I'm showing them to you. What's the difference between these 3 water bottles?
This one, the floor is here, so gravity is that way.
Okay, so you would say the floor is like that? The floor is that way?
This one's correct.
Okay.
And then the floor is like that.
You got it. How did you know? I mean, ask.
The ball looks like it's floating on the water, so I just assumed.
Right, no, you got it. So again, the water can be on top like this. You know,
the ball wouldn't
that
be
defies
floating.
physics. Would you agree?
Mhm.
Obviously, right? Yeah, you got it. Pretty easy. So this next one, again, it has to do with water as well.
Cool.
And in this one, I'm going to tell you the differences between these 3, but I want to see if you could tell me which one's which. So
Okay.
here I have a box truck, and it's halfway filled with water.
They're
The
on
diff-
different hills.
No. So the differences here is one is accelerating forward, one is accelerating in reverse, and one is at rest. So can you tell me which one's at rest?
This one's at rest.
B? Well, why would you say B?
The water isn't moving, it's flat.
Exactly, you got it, yeah. So which one is accelerating forward?
This one,
You got it, yeah. How did you know that one's accelerating forward?
the water would move back if the
You
truck was
got
going
it.
forward.
So the more dense goes to the back, and the less dense goes to the front, which is the air, right? That's pretty. You got it. Yeah. It's pretty smart.
Thank you.
Yeah. So this last one. Oh, another thing to note: when water's containing at rest, for example, in B, how would you describe the surface of the water when it's containing at rest?
Like what do you mean?
How would you describe the surface? Would you say it's level?
Yeah.
Yeah, level. What would be your definition of level? I guess.
Still, like,
Still, okay, that's a good one. The one-word definition will be horizontal.
yeah.
Yeah, because
okay,
if you
I see what
again, this is not level.
Yeah,
this
yeah.
is a slope. So again, horizontal, perpendicular to the vertical will be what level is, and
Yeah.
water shows us that, right? So number 1 tool for measuring level, by the way. So since we understand what level means and how water behaves when it's contained and at rest, so which one of these 2 represents level when it's contained and at rest? It's the obvious one. Yeah, you got it. So this is the easiest one, but the real reason I do this is because over 95% of the population, including myself and maybe you, have been tricked to believing this is what level means, even though we know it's this, and water shows us that. You want to know how we were tricked?
How is this one at level?
Exactly. Do you believe the Earth is a ball?
Okay.
Yeah, so NASA, they came to have satellites orbiting the Earth, so they need to know the radius of orbit if they're supposedly going around it, so they need to know the radius of the Earth. So they do tell us the radius of the Earth is 3,959 miles, which means there has to be curvature every mile, and every mile has to increase. So in the first mile, there's an 8-inch drop, second mile, 32 inches, and by the third mile, there should be 6 feet of curvature. So if we went to a giant lake or a giant body of water, to physically measure for this curvature, the surface is going to show us that it's going to be parallel to anything horizontal above it, but they're trying to tell us that the surface of water is bending 6 feet in 3 miles, and 66 feet in 10 miles, which is like a 6-story building. So this will be the number 1 experiment to debunk the ball Earth, a physical measurement of the Earth, water in specific. So if I was to ask you respectfully, what's the number 1 proof or reason that makes you believe that the Earth is a ball?
Just all of science.
If I was to ask you in specific, what science, I guess, tells you that the Earth is a ball?
Well, the Earth is actually an oval.
Ovalate spheroid, okay, I've heard of that.
Yeah. around the equator is where it would be the widest.
Sure.
There are also certain physics of how things drop to the floor. It's also the question of like, oh, the moon is also a circle, but the Earth is flat kind of thing.
Yeah. So when it comes to the lights in the sky, like the sun and the moon, I don't know what they are. You know, human beings have only gone so high, in my opinion. So anybody making claims about the sun and the moon is just a guess. Nobody knows what they actually are. And I would say that's a red herring when we want to establish what the dimensions of the Earth actually are. Because looking at the stars or the sky, it's not going to tell us anything about the physical ground we're walking on. So again, a physical measurement like this will tell us whether it's bending or not. Just before you go, I know it's a lot. You said gravity, the way things fall, kind of proves to you that it's evolved. The irony, a lot of people think gravity proves the globe. In reality, it actually debunks the globe. And the reason why is that, did you know that gravity is not a force, or do you think it is a force?
I do have to go, but I am curious. Do you have a degree? No. I'm asking out of curiosity. Do you have a degree?
No, I do not have a degree.
Okay.
Yeah, so I just understand reality for myself, and anybody making claims that contradicts physics, for example. So if you came to me that you can walk on water, I can honestly just say that that's bullshit, right? Unless you could show me walking on water, then I'll accept it. I don't have to believe it. So I don't have beliefs. So I accept reality for what it is. So claiming to me that water has the ability to bend when it's contained and at rest defies physics. Just like
the reason why I was asking about your major is because I was wondering if you were like a physics major or something.
Well, I think we all deal with physics every day. I mean, when you get up off your bed, you know, it requires physics to get up off your bed and walk. You know, so we're all physicists in a way. You know, existing simply and doing stuff. It's what a physicist is. See what happens. You know, cause and effect type of thing. So again, if you're claiming to me that water bends, that defies physics. That's no different than you claiming that you can walk on water. You know, so when it comes to gravity, just real quick before you go, I know they claim that it's a pull that this accelerates towards the ground, but like you said, when we go back to this other question with water displacement, when it's at rest or being accelerated, the water has to move relative to the direction of the container, right? So again, if I accelerate this way, the water moves to the back. If I accelerate this way, the water moves to the back. If I accelerate down, the water goes up and pushes the air to the bottom, right?
Yeah.
In free fall, that doesn't happen. The air doesn't go to the top because the bottle's not being accelerated down. What's happening is the earth pushing up against you right now. You're not being pulled to the earth. So this force of gravity is not a pull, it's a push. So it's the earth's motion that's creating your weight, for example. And because your body has inertia, it wants to remain still. That resistance of the motion is what gives you your weight.
I see.
So that's what's happening. So objects don't accelerate down. It's the earth that comes up to meet it. And physics shows us that, again, the fact that there's no displacement in free fall, and the fact that all accelerometers, again, if you have an accelerometer on your phone and you accelerate it in any vector, it's going to displace, it's going to show acceleration or a force. When you put it into free fall, however, it doesn't measure any force.
I see. Thank you.
So here, if you want to take this,
I came back.
Yeah. Have I spoken to you before?
I feel like it because remember the water thing.
Yeah.
When I saw the sun and he's like, oh, it's the TV show where he's smarter than a fifth grader.
Oh, no, it's not this. It's just my channel, but
Same
I mean,
idea?
yeah. Basically, I mean, you heard the conversation I had with her, you know, about. So, do you believe the Earth is a ball? You get right into it, I guess.
I mean,
I guess.
don't really care, but I guess.
You don't really care.
No, because like.
But do you believe it is, or do you not? What if you had to ask you, like, what shape is the Earth? What would you say?
Round, I guess.
Yeah, right. That's what you were told, right? So if you had to like quantify it or justify it, how would you do so? How would you justify the belief that the Earth is a ball? You wouldn't. You couldn't, right? So is it just something you would say you just adopted? That you were just told?
The idea was given.
Yeah, exactly. The idea. Do you think it's better to understand how substance behaves, for example, or reality, you know, for ourselves, or is it better to just believe someone?
Will believing that someone prevent a harm?
No, it won't. I mean, it could be detriment to yourself if you believe somebody that's telling you lies. You know, you don't think that people. I mean, that's how people take advantage of other people. Wouldn't you
Will
say?
it prevent a harm?
Will it prove any harm? Is what you're saying?
Prevent
any harm. Do you think it's okay to lie to children, for example, about their existence? I would say that's child abuse, in my opinion. So there is a lot of harm.
Harming them.
Do you think psychological harm is should be taken into consideration? Like, is psychologically abusing a child bad?
Yes, but lying to them depends on the lie.
Yeah, exactly.
It's either just lying or psychological abusement, right?
Yeah,
Depending on the lie.
yeah. Depending on the lie, I would say lying about our existence and what this place actually is, especially to a very small child, I would say that is psychological abuse. Making them believe in something that's not true, so that then they just take authority's word over their own experience and their own common sense. So that's how you facilitate somebody taking advantage of someone else. That's why deceivers, that's why they lie, to take advantage of people. So it does lead to a lot of detriment, in my opinion, and I think it's very important to understand that this place is not what we're being told. So there is a lot of harm if you really think about it. That I would say the dysfunction of society, it's because people are not properly grounded in understanding reality for themselves. They just take somebody else's word that they think they're smarter than them, and they just follow. So a lot of people are just followers nowadays. A lot of sheep. A lot of people are not independent thinkers nowadays, and that can lead to, a lot of crazy shit that we're experiencing now. Drug abuse. People just don't care about what their own life, let alone other people's lives, right? And it's all because people are not properly grounded in what this reality actually is. So if you believe that the Earth is a ball in an infinite vacuum of space and we evolved from monkeys, then you're probably not going to care much about others. But if you understand that this was intelligently designed and it has a purpose, then maybe you'll think twice about taking advantage of others or harming others, right? So it goes really deep when it comes to the why. What does it matter, right? So, but that's a completely separate question to the fact that we are being lied to. Again, physics showing us that it is, that it's not a globe, for example. It's a physical impossibility. So, do you have any questions for me? Have you thought about it since the last time we talked, or not?
Not really. People call it way too much.
No, I get it.
Almost no free time.
I get it. Trust me, I barely have enough time to do this because I actually have to work too. I work a full-time job, so I have to take time off to be able to come out and do this. And believe it or not, I get lazy too, because I don't want to take this whole responsibility on myself, and I don't. I do this kind of like for fun as well. It makes me feel good to share the truth, right, about this place. But yeah, I get it. You say you're easily distracted with your school and your day-to-day life, for example, yeah. And that's what they want everybody. If they can have everybody occupied, again, that's why your job is called an occupation. It's just to keep you occupied from actually asking real questions. So, well, I would say an occupation is a waste of time. Over 95% of jobs, in my opinion, are obsolete. In other words, they don't actually contribute to anything in society.
Would they give you an income?
I'm sorry?
Would they give you an income?
They give you an income because we created this system of economy. We shouldn't, in my opinion, this economic system that we created, it should be optional. So in other words, everybody should have the right to land. Nobody should be charging rent to anybody else. And if you want to work a job for your hobbies or for your addictions or whatever, then you do that. But the fact that we all have to work for basic necessities like shelter and food, that's how we're being fucked. And that's how we're being kept in the dark. By just keeping us occupied, distracted, entertained, and not actually sitting down and thinking about our existence.
So without an occupation, let's say we don't have to pay rent or nothing, right?
Yeah, exactly.
But let's say we want to eat, right? And for some reason, our piece of land where we put crops is not giving food.
I would say you should move to another area that you could.
Right, well,
a lot of times you could replenish the soil too. We don't know none of this. I don't know how to replenish soil, but there's people that do.
Yeah.
This is the things that we should be taught, how to refertilize the soil so we can actually grow food here. All of these things are basic traits as a human being that have been lost. So now we're living a substitute society, I would say. This is like it's being forced on us in a way. We're born into it. And because we're born into it, a lot of people think it's the norm. But in reality, it's not. We live in a cult, And that's just the word for culture. We live in cultures. Cult is just short for culture, But again, we could have good cultures or we could have bad cultures. I think we are living in a bad culture because the culture is taking advantage of us. You know what I'm saying? Or the government, in other words, the ones that present all of these ideas to us.
Going back to my idea.
Sure.
So you're hungry, your crops didn't give you food, right? Well, next to you is your neighbor's farm thingy, and then you be, hey, I want some, but he's like, no, this is I did this, or whatever, and since you don't have money or something to exchange for the goods, then you die, I guess?
No, well, even in this society, with all the economic stress that everybody has, there's still a lot of food. How would you call them? Food banks and stuff like that. Churches that give away a lot of food to people. So even in this shithole of society that we live in right now, people still help others. So for sure, people are gonna be helping each other out as well. You know, especially when they don't have financial restrictions, it'd be easier to help others. You know.
Yeah, but going back to my point, let's say the same situation. Farmer 1 has hungry because he doesn't have food. Farmer 2 has food because he doesn't want to give food to
Sure.
Farmer 1.
Sure.
So what does Farmer 1 do?
Farmer
Steal
1?
at night or something like that, right?
You're gonna have to do whatever you can to survive.
Sharpens his knife.
Right?
Yeah, that. I mean, that could lead to
but
that.
What's the opposite of benefits? Home benefits?
I'm sorry.
What's the opposite of benefiting?
What's the opposite?
Detriment.
Harming? Yeah, but the actions Farmer 1 does harm farmers too.
But here's the thing, just so I'm gonna easily debunk that claim. Right now in this society, guess what percent of the population is actually growing and feeding the rest of the population? What?
5, 10.
Right, less than 5%, right? So let's say at least 50% of us actually grew food. You really think we're gonna have a shortage of food? If less than 5% can feed the entire population, imagine 50% people actually were hands-on. Hunger will be obsolete. I'm sorry?
We currently don't have a food supply problem.
Oh, exactly.
It's a food distribution problem.
Exactly. But what he's saying is that, I guess my point is that if a very small percent of the population is able to grow and feed the entire population, in this scenario where you don't have to work and people actually grow their own food or gather their own food, hunger will be obsolete. You know what I'm saying? There'll just be an abundance of food everywhere. Like we could plant fruit trees instead of these fake trees.
I know, right?
Exactly. We could have a bunch of fruit right here, apples, oranges, you know, but why do we have these trees? Because it's a system. They want you to buy food from a market.
No, you can literally grab any orange off a tree that you see on
Yeah,
the
in
property.
public, exactly.
Really?
No, on this campus.
Oh, in this campus too?
Yeah.
Oh, yeah.
Yeah.
Oh, sorry. Oh. Thank you.
No, yeah, you can pull any fruit on
Okay.
campus. You can pull.
Okay. Sure, that's cool. But I would
There's
like.
probably some orchards where they're like, this is a specific experiment. Don't touch this because it may not be healthy for you.
Right.
But for the most part.
Now imagine that on a bigger scale, putting fruit trees in public everywhere, you know, instead of just generic trees, you know. That could easily, but that's the thing, that will mess up their food supply chain, their profits.
My
you know.
idea
Sure.
of why they don't do that, besides that, because it makes a lot of sense,
Yeah, sure.
is that so we grow waste because like they fall, they get smashed, and people want to eat it because it's already on the floor, right?
Yeah, sure.
So who's gonna clean them? The insects, the animals are coming. So that was my belief of why they don't do fruits.
Okay.
Now
You're saying like just for health, kind of like health, cleanliness, health. Okay, that could be a
maybe not as big as yours.
Sure.
Small.
Sure. I mean, those are problems that can easily be solved. You know, if you ask me. I mean, we have street cleaning that passes through my house twice a week. You
And
know,
they're getting paid.
Exactly.
That goes against what you're saying.
if you keep your area clean, then everybody can keep their area clean. And in areas that no people live, well, I guess those areas will just. I mean, once the fruit falls, it just becomes soil again. It dries out.
If it's in the dirt.
Yeah, I mean, eventually it dries out, it becomes powder or dirt again. You know what I'm saying? So it's not really waste. We're creating the waste with plastic, you know, everything that humans make, all the materials that we make, that's creating the waste. Trees cannot create waste. It just becomes soil again. Any fruit that falls on the dirt. You know?
Okay.
You know, so again, it just solves itself. You know, all these problems will solve themselves. You know what I'm saying? But again, it comes back to basic fundamentals about how this reality works. You know, if I may ask you respectfully, you believe the Earth is a globe, right?
Yeah, I believe it's fair.
If I was to ask you why, what convinces you that it is a globe?
Lunar eclipse.
Lunar
Shadow
eclipse?
of the planet.
I'm really sorry to interrupt you, but
Sure,
I
sure.
don't want to interrupt again later
Sure.
on. I'm a late because I have a request.
Okay.
It was nice catching up with you. Next
Yeah.
time I see you, come back.
No, yeah, definitely.
Okay.
Appreciate it, man.
Good luck on your quiz.
Yeah. So a solar eclipse is what convinces you?
No, lunar eclipse.
Oh, lunar eclipse. Okay.
Yeah.
So what about the lunar eclipse that convinces you that it
The
is?
shape of the Earth's shadow.
Okay. So you assume that the sun. You assume that the heliocentric model is true and the sun is.
No, I don't assume.
How do you know then?
Because of, what is it called? Like the retrograde tracks. So when we had an Earth-centered view,
Okay.
some of the planets had to do like these loop-de-loop type of orbits in order to account for them appearing to move backwards in our sky. However, that problem is solved based around a sun-centered solar system.
Okay, let's say that was true and the Earth was a globe. Should we be able to physically measure that curvature here on Earth, or is it not possible to measure it?
Yeah, I believe if you have a stick, so like I think they did it with obelisks back in the day, where they had like one obelisk, let's say, what is it? It's like different latitudes, right? So we have one obelisk at like a latitude that's closer to the North Pole, and another obelisk that's on the equator. So the shadows that is cast on those obelisks during, let's say, high noon will be different angles, and so like from those differences we can then calculate the size and shape of the Earth.
Did you know that that observation of measuring the shadows in different locations and getting a different length can also work on a level Earth with a much smaller sun locally? So if a sun is actually local and much smaller than what they're telling us, it will still give us the same results over a plane. For example, if you have a light source that's right above you here locally, it's gonna, if you're right under it, it's not gonna cast a shadow.
So
But the further you,
how far?
what do you
Like
mean?
what?
Oh, I don't know the distance to the sun
Oh,
exactly.
then I can't really.
Do you know the distance to the sun
You gotta
in the
give me
heliocentric model?
something. Yeah,
What is it?
it's 180.
In miles.
Oh, I don't have that number.
Okay, it's 93 million miles is what
Yeah,
they
and it
claim.
varies by like.
So how did
hundreds of
they
thousands
measure
of
that distance? if I may?
Trigonometry.
Did you know that distance actually changed
Yeah.
from 1 mile all the way up to 93 now? So when they first proposed the distance to the sun,
I bet. I mean,
Yeah.
I hope so, right? Because the more information we get, the more accurate we
okay,
can make
in
things.
trigonometry, I'm glad you brought that up. I don't know if you knew, measuring angles to the sun or the stars using trigonometry only works from a level surface because triangles don't have curved bases.
I've literally done trigonometry problems in 3D space, so I'm not too sure what you're referring
So if you
to.
have a curved surface
Okay.
and you're measuring angles to the sun, from a curved surface, the angle is always going to change because you're going down a curve post and measuring an angle. So
But
you
the
do.
point's still the same, so
Yeah,
I
the
understand.
point. My point is that the only way to actually get accurate measurements of luminaries in the sky, stars, sun, it's only possible from a level surface. That's my point. To measure angles, you
So
need
like
a level
to
surface.
shoot a distance to.
To measure the angle.
What does it matter what platform it's on?
Well, that's
Because that's what you're saying. You're saying the platform of which the measurement's like happening.
Okay,
matters. It
so
determines the
let me explain to you. So
Yeah.
if we're on a level surface, right, and we're measuring a luminary that's right here, for example, or just in our visual space here,
Yeah.
if we start walking backwards, that's gonna appear to drop due to perspective.
Okay, so if you change the location of the measurement.
yeah, so
Okay.
so again,
So you didn't say that the first
Yeah,
time.
my
Well,
bad.
yeah, if you change position, it's going to change the measurement.
exactly. So on
Okay.
a curved surface, you couldn't measure angles to be congruent with each other because as soon as you start going down this curve, you're
Yeah,
not
as soon
measuring the
as you
same
start-
angle anymore.
Yeah, as soon as you start moving,
Yeah.
of course the
So for
observation's gonna change.
navigation, in other words, the trigonometry that's used or the celestial sphere,
the sextants,
the celestial
right? That's
exactly,
what
they only work over a plane because you're to navigate, to move and keep the same angles relative to your last position. It would have to be an equal surface.
So you don't think they change the angles or anything like that?
From a globe
don't-
perspective, it wouldn't even work. All the numbers wouldn't be congruent to each other. You'll have different angles from somebody standing here to somebody standing over here.
Like I've spoken to people who captain boats,
Right.
and they don't agree with you.
Well, I would say that they follow the celestial sphere concept to navigate, and the celestial sphere is due to perspective. So an object, for example, this tree.
But you're saying it doesn't work. So if they're telling me like, yeah, you know, I go on boats, like this is how
Okay.
I do it, and it works. So then I don't really understand. Right? Like
Okay.
if it is flat, then
Okay.
it shouldn't work for them.
No.
Right?
Okay, so the celestial sphere that they use to navigate is due to. So, for example, I can measure the top of this tree, for example,
Yeah.
and I can measure the angle. We'll say 45 degrees, for example, right? If I walk backwards or on a level surface, that is gonna appear to drop in our field of view because everything shrinks to a point. The
What
further
do you mean
something.
by that? You said that's going to drop in our
So
field of view. So
it's
like
gonna.
the trees
So
going to
would,
drop in the field of
no,
view?
no. In your field of view, it does appear to drop because everything shrinks at a distance. Would you agree or disagree that objects appear to shrink in your field of view?
Yeah.
Yeah, everything gets smaller until you can't see it anymore, right?
Yeah.
So when I walk away from this tree, for example, this 45-degree angle that I'm measuring right now, when I walk back over a level surface, it's gonna appear to drop in my field of view only because it's shrinking. So what they're trying to tell me that it's not actually dropping in your field of view, you're going down a curve. That's what they're trying to tell me.
Okay.
So an explanation could work both ways. Is my point. So that doesn't prove
So
either
how
or.
does that work with the boat captains using a spherical model and then still being able to use sex navigation properly when you claim that they should not be able to, right?
No, they
That's
use
what you're
GPS.
saying?
A lot of navigators nowadays just use GPS. Not a lot of them use the old school way of navigating.
Isn't GPS also based on a globe?
No, that's just a projection. The globe is just a projection. So yeah, they are traveling using GPS, but what they're seeing in their graph is just a projection. So the actual physical distances you're traveling
I'm referring to the satellites, right, that are orbiting the planet.
Right. So yeah, again, all of this.
Right, because isn't that how GPS works?
Well, if you actually look into it, over 95% of communication here on Earth, it's all underground cables and ground towers. So no signals are coming from satellites. If anything coming from above is satelloons or high altitude drones. So satellites floating in outer space. Again, outer space is just a concept. It's not real.
Oh,
And this is how easily you debunk outer space. In order to have two opposing pressure systems next to each other, you need a solid barrier.
I don't think so.
So can you demonstrate a higher pressure without a container?
Yeah.
How?
So, right, when there is, so like here on Earth, it's very difficult to demonstrate those things.
Yeah.
Just because I don't know, you could say like the parameters are a bit different. However, when you're in space where there's different parameters, then at that barrier, you basically have the container is a force. So like how we have the electromagnetic force, the weak and strong nuclear forces.
Right.
There's also like the force of gravity. So that force is what helps, keep things together.
Yeah. So here's the main thing about this topic, and you brought up gravity. So gravity, you believe, is a force, right? A universal force, or a force that pulls objects towards the center mass. Or what do you think gravity is?
I think gravity is the label we give to the phenomena we see.
So so if I release this object, for example, you believe this object got pulled to the ground by gravity or force of gravity?
Getting pulled to the center of the earth.
So the fact is,
like if we were to crawl to the center of the earth, we'd be weightless.
okay. So here's the thing. I don't know if you knew this.
Given that we can survive all
Have you heard of Einstein's theory of relativity?
Yeah.
Yeah. So he claims that gravity is not a force.
Okay.
So, and the reason why is because when you release an object into free fall, there is nothing acting on it to accelerate it. So in reality, it's not accelerating down towards the Earth. It's what's happening is the Earth right now, it's pushing up against you. So the Earth is moving. So it's in motion.
Yeah, the Earth is, I agree.
It's
the Earth
moving
is in
up.
motion.
And when you release an object, it simply starts to lose momentum. So because of inertia, the object wants to remain motionless. So when you release it, if it's more dense than the air, that means the air can't push it up anymore. So it appears to go down, but it's the Earth that's coming up to meet it.
What is density?
Density is how much mass per volume an object
why
has.
is it that more dense objects
Because
end up going under least dense objects?
Because the air is not dense enough to push it up. Because the Earth is pushing up on the air, creating a pressure gradient. That's why the air has pressure, because it's being pushed.
How did you measure that the Earth is pushing up?
Oh, easy. You know what buoyancy is? Buoyancy, when something floats in water, or when you lit a helium balloon, it goes up.
Yeah.
So buoyancy is the effect of a contained system that's in motion. So for example, here, let me show you. Fuck, my phone's overheating. Okay, so I don't have my phone, but so I did an experiment with a cargo van, and I put a helium balloon in the cargo van. And the helium balloon obviously is vertical when it's at rest. When I accelerate that van forward, for example, what happens is the back of the van, the solid door, starts to push the air in that direction, which creates a pressure gradient, and that more dense air pushes the helium in that same direction because helium is less dense, right? So if I have an apple there hanging, the apple is not going to get pushed like the helium balloon did. The apple is just going to swing back, or appear to swing back when I accelerate the whole van forward. So we have two motions there, of the apple appearing to go back and the helium balloon going forward with the direction of the force.
Well, it's mainly the truck is moving forward. The
Exactly.
apple's staying in place.
Exactly. So here on Earth is the same principles. The air is pushing the helium up, and the air is being pushed by the ground because the helium is less
That
dense.
still didn't answer my question. question. How did you measure the force that the Earth is moving up at?
When an air bubble rises in water, that shows you that the Earth is pushing up. Matter cannot move
I'm
on
not
its...
asking you how do you know that the Earth is moving up. I'm asking how did you measure the force? Like how much
Buoyancy is the force of it's the effect of a contained system that's in motion. Buoyancy. So when you release a helium...
Yeah, but you're still not answering my question about the Earth. You're giving me examples of like a van and of your water bottle, but like how did you measure that for the Earth?
If I have an air bubble here, and if I blow an air bubble here, for example, what direction does it go? If I blow an air bubble, if I had a little hole and I blew an air bubble, what direction does that air bubble go?
It depends on where it's at. If
It's in the bottom, for example,
then the water's going to displace it.
In what direction?
Well, the air bubble will go up.
Exactly. Why does the air bubble go up?
You're still not answering my question, though.
No, I'm getting to that.
Okay.
Why is the air bubble going up?
Because the water displaced it.
How did the water displace it?
Because gravity pulled the water down.
So do you agree or disagree that when an air bubble is rising or a helium balloon is rising in air, would you agree that the medium that surrounds it, that's more dense, is pushing it up? Would you agree or disagree? No?
No.
So how
it's because the area that's around it that's more dense is coming down and it's settling due to gravity. And so because it's settling, it's basically forcing the lighter, less dense material up.
So you're saying gravity is pushing helium up?
No.
What's pushing the helium up?
Gravity is pulling more dense gas down, and that more dense gas coming down is displacing the less dense gas. Kind of like, have you ever seen the...
No, I get what you're saying.
Let me give you an example as well. You have a cup of carbon dioxide, and you have a candle. Now, when you pour the carbon dioxide down, it's not that the carbon dioxide is pushing the oxygen up, or that the Earth is pushing the oxygen up. It's just that the carbon dioxide is displacing the oxygen, and it's moving it somewhere else. Whether it goes up or off to the side, it doesn't really matter.
Okay. So displacement, right? Would you agree that displacement only happens when there's a force present?
I don't know. I'm not a physics major.
Okay.
But I would kind of guess that displacement occurs because gravity's pulling it down, so it's displacing.
Yeah. So I could show you here. Let me show you this real quick. It's better if you
still
actually.
Haven't answered my question.
It's basically this simple. Look. Let me just show you so you can see it, because I don't want you to think I'm making it up. But again, you can recreate this for yourself. I don't know if you could see the helium balloon there.
Yeah. Oh, yeah, no, I've done that. I've had helium balloons in my car.
So the only way for the medium to push on the less dense medium is for the medium to also be pushed in that same direction. So the air in this example, with this example.
So in your van, you were able to then extrapolate that out to every situation to make it a universal law?
That's a basic law, that buoyancy is the effect of a contained system that's in motion, and buoyancy shows you the direction that the force is being applied. Force is motion. Okay. So again, you need to have a containment, you need to have substance in there, and that substance needs to be also being pushed in that same direction that is pushing the less dense, because matter cannot move on its own. Matter doesn't have the ability to move itself, or do you think it does? It requires...
I move myself, so I don't really... I think that, like, you're moving yourself.
Yeah,
so
we're talking about life force now, about consciousness. I'm talking about inanimate matter. Because obviously, if you die, your body can't move on its own. It requires your inner force, your life force, right?
Well, it requires electrical impulses.
Yeah, whatever. So
yeah, whatever.
Okay, no, yeah.
It requires electricity.
Sure. It requires a cost.
You could say electricity
a cost.
Is a
Let's just say that cost. In order for something to have motion, it requires a cost. Would you agree or disagree?
Once again, I'm not a physicist, and I've heard some weird stuff in physics. But let's go with yes. Okay,
yeah, it requires a cause. If you claim that matter can move on its own with no external cause, I would say that's just that has never been proven.
This is not my specialty.
Right.
What I've heard from people who are physicists, there is an issue concerning cause and effect.
Right. So
not always cut and dry.
Right. So the fact is, when you release an object into free fall, there is no cause or something that's making this accelerate down. How do we know that? Well, that's the thing. I don't know if you knew. Have you heard of Einstein's theory of relativity?
You've already told me
okay.
that, so I hope you think I know, because you literally said
so
that.
He acknowledges that there is no force in free fall. In other words, there is no acceleration. So he has to come up with the bending and warping of space-time, which is just a concept that supposedly space is flowing down and is dragging everything down with it at a constant, even though it's an acceleration that we witness. But now they're claiming it's a constant, this flow of bending and warping of space-time. The only reason why he came up with that explanation is because they need an explanation to push the globe model. Because if they don't have that acceleration, Well, the people that, the governments for sure, the people that put this out there, you
So,
know,
like,
and
which
teach it.
governments?
All governments.
Like,
Have you heard?
Literally all governments.
Have you heard of the UN? Or anybody that's part of the
Yeah,
UN?
not all. Okay, so like the UN. So
The
not all governments, just the UN government.
Mainly the UN, sure.
Mainly?
Maybe, you know, mainly. I would say anybody that's part of that is for
How
sure.
long has the UN been around?
Probably the 1940s, I would assume, when NASA was
How long
established.
has humans thought the Earth was round?
Around where NASA was established.
Really?
Yeah.
So you
Yeah.
don't agree with
That's the whole-
historians?
That's the whole reason why they came up with
what is it,
the.
like Aristophanes?
Right.
You don't believe that?
Nah, I don't believe in stories. I either know
So, like,
something.
you don't believe history at all?
I don't believe history at all.
is
Especially
that?
if history, if there's a story in history, for example, Jesus walking on water, that contradicts my physical reality, then I can honestly say that that's bullshit. It's like,
So, like, you think Jesus is bullshit?
I think so. Anybody that claimed that man walked on water, in my opinion, they are bullshit. Because that defies physics. Might as well, they could easily put in there that he walked
So
on air.
Anything that defies physics
Yes.
is bullshit. So, like,
Yes.
all miracles are bullshit.
Well,
'Cause
miracles.
miracles by definition is something that defies.
Well, that's what doctors or whatever.
No, that's what I've heard from theists.
Sure, or whatever. If they do say that, then I would say that's their opinion. Sure. This is just my opinion. You know,
So
I'm not
are
saying.
You when you say opinion, are you talking about the definition of what a miracle is? Because that's what I was discussing.
What is a miracle? I guess if I may ask you, I guess.
A miracle is what I just said, right? It's an event that defies the laws of physics, as we know.
So, for example, if you told me that, oh, it was a miracle that a pig flew, like
Or it
obviously,
was a miracle that a pig's head got chopped off, and then we just stuck it back on, and now the pig's fine.
oh well, I would say that there is something to that. I wouldn't deny it. If you can demonstrate that the pig's head got cut off and they were able to sew it back on and he's fine, I'll accept
I'm
that.
not able to demonstrate.
Oh, exactly. But if you could demonstrate
No,
me
but
that,
that's what I'm saying. Like
yeah.
in this example, right?
Yeah.
Because usually when
I would-
it comes to
Sure.
miracles, they're not demonstrable. Like all of Jesus' miracles, they're not demonstrable. You think those are bullshit? I think they're bullshit too.
Yeah, yeah.
So like, if a miracle can be demonstrated at that point, it would then conform to the laws of physics, or
It wouldn't
would
be a miracle anymore. Yeah,
Exactly.
exactly. Yeah, so for me, miracles are just claims that people make. Or for example, like somebody cured cancer,
I mean, I would
and they say,
agree.
oh, it was a miracle that they cured cancer, you know, it went away overnight. I would say there is another reason why it happened. It wasn't just a miracle. It wasn't just God pressing a button and you're healed now. There was something physically that happened that made that tumor go away.
Yeah.
So just because I don't know that what happened, that doesn't mean, oh, it's a miracle. It just means I don't
The
know.
bell tower went off.
Yeah.
I
All
gotta
right.
go to
I meant
class.
no worries.
How
Yeah.
often are you out here?
I come here maybe once every 2 weeks. I mainly go to USC as well. I come here, I go to UC Irvine. This is the #1 censored topic online, so you're never going to catch someone like myself speaking about this the way I do. Over 95% of flat earthers are just talking a lot of shit. Just basically, they're falling into another psyop. The main psyop is that they believe the
But
earth
you're
is...
different, right?
Yeah, they believe
You're the
that...
exception.
Because I go with physics. I go with physics.
And like none of them go with physics.
Nope, they deny that
Even though nothing you've told me, I haven't heard before.
Exactly.
I've heard it from other flat
Yeah.
earthers. So like, you're
So-
not that special.
Ask any other flat earther if the earth is motionless or not. So they deny the cause to objects appearing to fall. They come up with another bullshit explanation just like the ball earth. You know, they say it's RDD or some other bullshit, but the fact is objects don't accelerate down towards the ground. That's the biggest lie on earth, by the way.
Next time we talk, I'd like you to explain what the shadows on the moon during lunar eclipses are around.
Well, I would say that's a red herring when it comes to the shape of the earth.
Well, then explain that to me. I have to go to class, but
Sure, it is.
I'll
Well,
explain
yeah,
again.
yeah, no worries.